A pleasant day to you all viewers. Welcome to this production brought to you courtesy of Kunyu's Electronic Academic Solutions. Passion Yasha Mwanjiambira is my name, and I'm here with my partners, Kudapasha Mwanjiambira. Hello viewers. And Mr. Tinashe Obechiko.
What's up viewers?
The Maths Guru Chico Swag, who's going to elaborate to you on vectors, why they're important in our day-to-day lives, and why they're relevant to our mathematics O-level syllabus. Wow, Maths on DVD. What a brilliant idea. I wish such an opportunity was granted to me back in 2008 before I wrote my mathematics examination. I guess a DVD is user-friendly. What do you think, Kuda?
Yeah, surely a brilliant idea indeed. I'm especially thrilled with the idea of rewinding and repeating a concept till it sinks into the brain cells. And also the idea of forwarding and skipping the irrelevant material, going straight to the desired concept for clarification. I think this is an innovative, educative, and informative initiative.
That's very true, Kuda. Mr. Chico, tell us, how did you come up with such a brilliant idea of audiovisual learning?
You see, Patience, from the vast experience that I have as a teacher, I realize that most students, when they come into a classroom, right, they understand concepts. Some of them masquerade as if they are understanding, while they are not understanding anything. And others, after understanding, the moment they go outside the lecture door, all the information evaporates and condenses elsewhere. So that's when I realized that, okay, if a student can be able to know a rap song or a blockbuster movie from the head and forget a concept, an educational concept, right? How is it possible that a person can know that and forget this? So that's when I realized that, okay, first of all, the concept of repetition, continuous repetition, will make information to sink into the brains. So that's when I realized that, okay, we can also put academics in that channel.
Mr. Chico, thank you very much. Viewers, you've heard for yourself. Over to you, Kuda.
Mr. Chico Squared, may you please state the content of this topic?
The topic content for this lecture, number one, we are going to look at translation, vector translation, in terms of representing a vector with a line segment and also vector notation. Number two, we are going to look at operations of vectors, right, in terms of addition and subtraction of vectors, multiplication by a scalar, and also to calculate the magnitude of a vector, right. After that, we are going to be looking at the concept of position vectors. We are going to look at parallel vectors, and last but not least, we are going to look at properties of shapes in vectors.
Thank you, Mr. Chico Squared. May you kindly outline the aims and objectives of this lecture series?
At the end of this lecture, students must be able to know the following concepts. Number one, students must be able to define what a vector is, right? To differentiate between vector and scalar quantities, right? Number two, to represent vectors on the Cartesian plane, and also to represent vectors in column matrices, right? Students must be able to calculate the magnitude or the modulus of a vector. Students must be able to know the relationship between parallel lines and vectors. Students must be able to know and to use the addition law of vectors in simplifying vectors in properties of shapes. That's basically the main elements that we need to cover in this lecture.
Mr. Chico Squared, to ensure the viability of this lecture series, what source of material and aids are you going to employ?
As source of materials, I'm going to be using the Golden Book of Mathematics. Number one, I'm going to be using the Zimbabwe Schools Examinations Council syllabus booklet, and we are on page 12. Number two, I'm going to be using the traditional mathematics textbook, the New General Mathematics Book 4, written by J.B. Channon, A.A. Chasakara, and others. I am also going to be using Zimbabwe Schools Examinations Council past examination papers and questions.
Last but not least, in a normal classroom setup, it is a norm that there's supposed to be teacher-pupil interaction. But Mr. Chico Squared, now this is a DVD. How are you going to ensure that there's interaction between the teacher and the pupil in terms of teacher-pupil activities?
Teacher-to-student interaction in this DVD is very possible. To ensure that we achieve teacher-to-student interaction and student-to-student interaction. Number one, when watching this DVD, I advise you not to watch this DVD as if you are watching a blockbuster movie from Hollywood, right? First and foremost, you need to watch this DVD with your brains intact. Number two, you need to scribble some notes and also to participate in our problem solving here while you are at home. Do not just sit as if you are a stooge and do not be absent-minded. Number two, I also encourage that you indulge in group discussions. You can indulge in group discussions with your peers, right, with your fellow students, right? You can watch together, and you can also seek the counsel of another professional mathematics tutor.
Thank you, Mr. Chico Squared. Over to you, Patience.
Thank you, Kuda. Thank you, Professor Chico. In vernacular we say, Anenzere Anzwa. So viewers, a new dawn has come. The good news has finally come your way, which is going to remove that blanket of confusion on vectors. So let us all sit back, relax and absorb as our maths guru Chico Squared enlightens us on vectors. With that, have a happy viewing. I salute you. Over to you, Chico.
Ladies and gentlemen, let's get down to business, right? As was being said by my co-presenters, right? Today we are looking at vector geometry, or some people call it vectors. That's the popular name for this topic. When I mention the word vectors, most people shiver as if they have seen a ghost. Why? Because most people have been fed by malicious propaganda by their predecessors that vectors are very difficult, aren't they? The people that studied mathematics before you corrupted your minds and told you that vectors are very difficult. They can't be comprehended by any person. But I am here to address this issue once and for all. Number one, never allow to be fed with information that is that is contrary to progress, especially when it comes to maths and everything. Number two, vectors are very, very simple. In maths, if you want to be a guru, you need to practice regularly. If you practice, practice and practice, you become perfect, perfect and perfect. Right. In this lecture, there are some assumptions that I want to lay, and there are some information that I want to give you, right? The first assumption is that you studied mathematics from grade 1. So I am not here to waste time on pertinent issues. I'm not here to waste time teaching you how to solve fractions, right? There's a DVD for that, right? And the second assumption is that you know the following topics. Number one, you know how to solve simultaneous linear equations using the substitution and the elimination method. Number two, the assumption is that you are able to expand brackets, right? It's an algebraic concept. You are able to factorize algebraic expressions. And number four, you are able to solve questions on ratio, proportion, and scale, because these are some of the dominant concepts that are going to come, that are going to be part and parcel of this lecture. I am going to try to move with a moderate speed that is conducive for all classes of students, right? Both the fast absorbing students and the slow absorbing students, right? So that you can understand. And then I am going to use multiple languages. To be precise, I'm going to be using the English language, and I'm also going to be using the vernacular Shona, so that some of these concepts can cut across into your cerebral hemisphere without much difficulty. Right. Handembe nenyaya eluyanas. My vectors, right. Let's start by defining what a vector is. Right? I want you to write the following note. A vector is a quantity with magnitude and direction, right? There are some key words here. There's a word called magnitude, and then there's a word called direction, right? Some of you, this is a new word to you, magnitude. Don't worry, I'm going to explain everything, right? A vector quantity is a quantity with magnitude and direction, right? The opposite of a vector quantity is called a scalar quantity, right? And the difference between a vector and a scalar quantity is that a vector quantity contains magnitude and direction, but a scalar quantity contains magnitude only, there is no direction. And mudzidzisi muri kuti chii mukurarama kwedu zuva nezuva in our daily lives, and there are many quantities that we use, and we use quantity mass. And makabva kuendesa mwana kuskero last week, and mukanzwa kunzi mwana ari kurema 20 kg, and mota dzenyu dzichifamba murodhi vanokomplaina driver ari kufambisa stereki anga achifamba ne 20 km/h. Imwe quantity kainonzi speed yataurwapo, quantity inonzi mass yekuendesa mwana kuskero. And vamwe vanotaura vana vakamhanya 100 meters, imwe quantity kairi kutaura nezvayo inonzi distance. And but ukatarisa ma-quantities ese atinoshandisa in our daily lives, the quantities that we use in our daily runnings, you will realize that these quantities can be classified into two major categories, right? The vector and the scalar quantities, right? Ma-quantities ese anenonzi magnitude. And when we are talking about magnitude, we are talking about the size. And mwana airema 20 kg. Saka 20 kilograms, that's the magnitude, no size. And vakamhanya 100 meters, 100 meters is size. And so magnitude, of course, zizwiri rakakura zvotinogona zvitsenga rurimi uchizama kutaura, but harina kana basa rinongoreva size chete, handede titese baba. So vector quantities have got magnitude and direction. Ma vector quantity anotaurwa size otaurwa direction, and the car is traveling 20 km/h northwest. That's a vector quantity. The moment we talk about direction, it becomes a vector quantity. The moment we only talk about magnitude chete, that's a scalar quantity. Let me give you an example. Mwana kuskero akarema 20 kg, and asi 20 kg is panombotaurwa kuti mwana akarema 20 kg ari kuwest. Aiwa pataurwa izvozvo. That shows that it's a scalar quantity and it's not a vector quantity. I think I have talked much on the definition of vector quantities. I don't want to overemphasize that point. But what I'm just going to do is that I will give you examples of vector quantities. We've got a vector quantity known as velocity, right? Velocity is a vector quantity, and a velocity na speed azvinambonyanyosiyana. Zvakangosiyana pakuti speed is scalar quantity, haitaurwe direction. Velocity yava vector quantity because yakutaurwa direction. And then we've got a quantity inonzi acceleration. It's also a vector quantity. Acceleration is the rate of change of velocity. Of course, I'm still in physics, in mathematics. We've got a quantity called force. A force is a push or a pull. And so a force is not specify our direction. Wafamba ma Newton mangani kupi kwacho. Wafamba 20 Newton outside kupi. And there are many examples of vector quantities that we have in our daily runnings. And scalar quantities, we've got one distance, we've got one mass, right? And kuma vector quantity ndatosia kuna na weight and kuna na displacement, and all these are vector quantities. And then, alright, tataura definition ema vector quantity, tapanana ma examples, and right. Then imwe issue yandinoda nditaure nezvayo iri of paramount importance inyaya yetranslation. And the translation, we are talking about movement in a certain direction without turning. That's a translation. And if I move from this point to that point, pane pachinzi paitika translation. This is now botena, right? That's a translation. And the person pane vector quantity paita translation. All right. Let me put this point across. I know that you are familiar with the Cartesian plan, and the Cartesian plan comprises of the horizontal and the vertical axis. Cartesian plane in a vertical y-axis, in a horizontal x-axis, right? Let's suppose we have a translation in the Cartesian plane. We have a particle iripa point A yamuva kuenda ku point B, right? In this direction, if vector kai was in a direction, arrow shows the direction, and vectors can be represented using line segments. Right, point A and point B are points in the Cartesian plane. Point A has got coordinates 1, 2, and then point B has got coordinates 5, 3 in the Cartesian plane. The vector going in this direction, right? A vector, or rather vectors, can be represented using various methods, right? You know the vector notation, right? Again, vector notation, right? In this particular example, translation move from point A to point B iri representwa using small letter A. Right? So what it means is that this small letter A is representing the translation from A to B. Right? Kana tichidila the vector notation, my ways, my methods atoshandisa ku represent my vectors, right? Akamira so, anele. This movement from point A to point B is also known as a vector AB. You can represent it as vector AB. Wocheta cut square pamsoro, anele. You can represent this as vector AB. Wocheta arrow pamsoro. This is the more popular representation used by many examination boards, including our own Zimbabwe Schools Examinations Council. Right. You can also have vector AB represented pakadakenwa, so A wakadakenwa, B wacho wakadakenwa, and this is also in the notation inoshandiswa to represent this translation vector AB, right? We also have, but this is very unpopular here, we can have AB wakadaiso as potential grid. This is also representing vector AB in the notation. I'll put my stars banner for my most popular vector notation methods and or since this translation AB yapi was zitara small letter A, and we can also represent this as A tocheta square pamsoro. We can represent this as A tocheta arrow pamsoro. We can represent this as a darkened, a bold letter A, or we can represent this as A potetwaka grid buzzers, but these are the most popular methods used by many examination boards. I've never seen this in use in any past examination paper, but according to theory, this can also be used to represent a vector. This is the vector notation ESA. It will represent this translation from point A to point B. And right, let me further explain something here. As you can see, to move from point A to point B, and pane movement yaitika parallel to the x-axis. And movement from point A to point B. Pane movement yaitika parallel to the y-axis. And as you can see, parallel to the x-axis, to move 4 units from 1 to 5, that's 4 units, right? And then panapa along the y-axis from 2 to 3 to move 1 unit. Apa to move 4 units to the right, kuratichi increase x. So which means that a positive movement, because that increase x. And apa ukacheka foot, tafamba 1 unit along the y-axis, tichi increase y. So this was a positive movement. And the movement yaitika parallel to the x-axis, but gender in the left, tichi decreaser, we would call it a negative movement. The point B, angry 4 units to the left, we would call this negative 4 because we are decreasing. And the reverse is also true for the y values. Alright, let me not overemphasize that point. Okay, so movement tafamba parallel to the x-axis, tafamba parallel to the y-axis. The question that can bump into your mind is that, what's the relevance? Okay, the relevance is that when representing this vector AB using a column matrix, by the way, vectors can be represented using a column matrix. And you know the column matrix, it's a 2 by 1 matrix represented in the following form, xy. And vectors can be represented using this column matrix form, whereby x represents the movement parallel to the x-axis, and then y represents movement parallel to the y-axis. And so using the column matrix, when representing this translation from vector from point A to point B, we can represent this as vector AB being equal to 4, 1. Because to move 4 units parallel to the x-axis, to move 1 unit parallel to the y-axis. And then, okay, now, in my concept here, apa tanga tichitaura nyaya yekuti vector AB, meaning to say that she move from A to B, but we can also consider vector BA that is moving in the opposite direction at chifamba nayo. And then mutemo wema vectors and unoti joni, when you are moving in the opposite direction, this is now negative. Hello? I hope you understand. Right? So this vector becomes negative. Okay. Let's consider translation from point B to point A. Maybe you get what I want to say clearly. And translation B when A, movement along the x-axis. Tiriku move 4 units, but tichi decrease. So Shatiru move 4 units, tichi decrease. And along the x-axis, parallel to the x-axis, it means that this is a negative 4 units. And then, like Jananchi illustrator, I hope apanam nangaji rasika angachi kanganisika mafungiro. Along the y-axis, the translation from B to A along the y-axis, as you can see, to move 1 unit parallel to the y-axis, but 1 unit yacho tichi decrease. So from B to A tichi decrease till parallel to the y-axis, this is -1. So as you can see, vector AB and then vector BA, sorry, vector BA is equal to the negative vector AB. Are we together? No relationship vector are negative, and I hope Majona, as we were illustrating using this simple translation method. Okay, this is a longer method. Let me erase everything here, and let's try to simplify. All right, can remove a message, right? All right, the reason why I was telling you this, it's because where are these things coming from?